One of the most exciting things about quantum in our present day is that we are transitioning from laboratory physics experiments like in the lab where we're standing, to actually taking those quantum tools outside the lab and trying to use them in significant and new ways. The Mount Blue Sky project involves comparing two of the most accurate optical atomic clocks ever created. One of those clocks is a transportable clock that we take to the top of the 14,000-foot mountain. We then compare it to a clock that's here in a laboratory at NIST in Boulder. That comparison takes place through free space over the air, and then they get collected by a telescope in Denver and then put in optical fiber to carry them the rest of the way back to Boulder. And it's the ticking rate of those two clocks that is then compared through this free space and fiber link. So the goal of that project is to test the theory of general relativity, that clocks at higher elevations will tick faster. So we want to verify that. That's something that Einstein predicted well over 100 years ago, and we think we can make the most accurate test of that theory. These kind of clocks could be important in building still more accurate and precise GPS. Being able to measure the shape of the Earth better tells us better where water flows. And that can be super important in low-lying coastal areas where even just a few centimeters of water spread over many square miles or kilometers is a lot of water, and knowing whether that flows towards a city or flows away from a city could in fact end up saving lives or saving property. The same kind of tools could maybe tell us about what's going on under the crust of the Earth, for example, with the motion of plate tectonics or magma, the fuel of volcanoes. If we could see that moving before it comes out of the ground, we could also potentially use these tools to save lives, protect property. Optical atomic clocks are the most precise and accurate measurement tools humans have ever created, giving us the capability to measure time to the 18th digit. And that kind of precision allows us, if we're able to translate the precision of those clocks to other types of measurements, such as geodesy or measuring the shape of the Earth, as we're doing in this Mount Blue Sky project. The precision of clocks it's like a super powerful microscope that gives us a view into the world, into the universe around us in a new and unique way.